Hello guys, I'm Said and welcome back. Today we're gonna solve logarithm questions. But first, let's review one important property that we will need for these problems. After that, we'll jump straight into the questions. Now let's look at the most general version of the power rule. If we have an exponent on the argument and an exponent on the base, we can bring both of them to the front as a fraction. The rule is this. The exponent of the argument n goes to the numerator and the exponent of the base m goes to the denominator. The rule is extremely powerful because it allows us to simplify complex logarithms by focusing only the exponents. Let's practice this rule with some examples and then we'll jump into the main problems. Let's get started. Let's solve the first problem. If a equals 3 to the power of a, so what is the value of log base 3 of 9a squared in terms of a? In terms of a, since a equals 3 to the power of a, so we have a squared equals 3 to the power of a squared, right? So a squared equals 3 to the power of a times 2 means 2a. Also 9 equals 3 squared, right? So 9a squared equals 3 squared times 3 to the power of 2a. So we have 9a squared equals 3 to the power of 2 plus 2a, or 2a plus 2. Now we take the logarithm base 3. So we have log base 3 of 9a squared equals log base 3 of 3 to the power of 2a plus 2. So we have the exponent becomes a coefficient in front of the log. So we have 2a plus 2 times log base 3 of 3. And as you know, log base 3 of 3 is 1. So the final answer is log base 3 of 9a squared equals 2a plus 2. Now let's solve the second problem. If log base a of 3 times the square root of 3 equals 3 over 4, so what is the value of log base 4 of a minus 1? First, let's rewrite the logarithmic equation in exponential form. As you know, when log base a of b equals c, so b equals a to the power of c. A to the power of c. So in this case, a to the power of 3 over 4 equals 3 times the square root of 3. A to the power of 3 over 4 equals 3 times the square root of 3. And we know that 3 times the square root of 3 equals 3 to the power of 1/2. Or 3 times 3 to the power of 1/2 equals 3 to the power of 3 over 2, right? So we have a to the power of 3 over 4 equals 3 to the power of 3 over 2. To find a, raise both sides to the power 4 over 3 means a to the power of 3 over 4 to the power of 4 over 3 equals 3 to the power of 3 over 2 to the power of 4 over 3, right? So we have a to the power of 3 over 4 to the power of 4 over 3 equals a to the power of 3 over 4 times 4 over 3 equals 1. So a to the 1 means a equals 3 to the power of 3 over 2 times 4 over 3 equals 4 over 2 or 2, right? So a equals 9. And we need to find log base 4 of a minus 1. A equals 9, so a minus 1 equals 8. So we have log base 4 of 8 equals log base 4 equals 2 squared and 8 equals 2 cubed. So we have 3 over 2 log base 2 of 2. And we know that log base 2 of 2 is 1. So the final answer is 3 over 2. Let's move on to the third problem. If log base y of x equals 1 over 3, so what is the value of log base x times the square root of x of y squared? First, rewrite the given equation in exponential form. So we have, if log base y of x equals 1 over 3, so y to the power of 1 over 3, y to the power of 1 over 3 equals x. This means that x cubed equals y. So we need to find y squared. So y squared equals x cubed squared, right? So we have y squared equals x to the power of 6. Now let's simplify the base. X times the square root of x. We have x times x to the power of 1/2 equals x to the power of 3 over 2. So this expression becomes log base x times the square root of x y squared equals log base x times the square root of x equals x to the power of 3 over 2, and y squared is x to the power of 6, right? So we have 6 over 3 over 2, 3 over 2 log base x of x, and as you know, log base x of x equals 1. So dividing by 3 over 2 is the same as multiplying by 2 over 3, means 6 times 2 over 3 equals 12 over 3 is 4.